Welcome back. Today, we are mastering the Subscription Status Badge Challenge, and we are jumping straight inside the Develow IDE. Before we write anything, let's get familiar with our workspace. On the left sidebar, we have the Problem tab. This is where our challenge is outlined. If you look closely, you will see our requirement matrix, which maps specific database statuses to friendly UI badges. Right below the Problem tab is our File Explorer, which holds our folder structure and all of our source code files. Down at the very bottom, we have our integrated terminal for running tests. Over to the right is our UI result pane, which will give us a live visual of the badges we are building. And finally, down on the bottom right, we have Develow AI. We are going to use Develow AI extensively today as a prompt engineering tool. Whenever we face an unfamiliar system or a tricky logic problem, we will use the AI to learn and guide our architectural choices. Before we do anything else, let's click on the Problem tab in the left sidebar to understand exactly what we are building today. Currently, our application takes raw subscription status strings directly from the database and prints them onto the user interface. It looks unprofessional and can be confusing for our users. Our main objective is to transform these raw backend strings into clean, user-friendly badges that use semantic color tones to give instant visual feedback. If you scroll through the problem description, you will see a requirement matrix. This matrix acts as our cheat sheet, mapping every possible Stripe status to the exact human-readable label and color tone we need to output. For instance, an active status needs a green success tone, while a past due status needs a red danger tone. Similarly, a trialing status maps to an informative blue tone, an unpaid status shares that urgent red danger tone, an incomplete status takes a yellow warning tone, and so on until every single backend state translates to a clean visual badge. But to accurately build this mapping, let's start with the most important step: understanding our data. Many developers jump straight into coding, but if you are unfamiliar with subscription systems, you need to know what the data actually looks like. Let's get to Develow AI and type our first prompt. I am new to billing systems. Can you explain what a subscription data model looks like in a system like Stripe and show me a mock JavaScript object? Looking closely at the AI's response, it provides an incredible, comprehensive breakdown of what a subscription actually is behind the scenes. It describes a Stripe subscription as a long-lived object that tracks a few core concepts: who the customer is, what specific plan they bought, how their billing cycle is scheduled, where they currently are in their life cycle, and any special termination flags. To make it easy to understand, the AI organizes this data into distinct groups. It starts with identity and ownership, which holds things like the customer ID. Next is the current lifecycle state, which contains the raw status string we are trying to map today. Then we have the billing schedule, which tracks the start and end dates of the current cycle. Right below that is termination behavior, which holds our crucial cancel at period end Boolean flag. Finally, it lists the pricing items, optional trial dates, and custom metadata. The AI even generated a mock JavaScript object for us to look at. If you examine this example, you can see exactly how the data arrives in our application. We have our status string set to active, our cancel at period end flag set to false, and a current period end timestamp represented in epoch seconds. But the most valuable piece of advice is at the very bottom. The AI explicitly warns us in its key point that to build our UI correctly, we cannot just rely on the status string alone. We must look at both the status and that separate termination flag to correctly communicate to our users that their subscription is active but scheduled to cancel. Now that we understand the data, let's open our File Explorer, go into the Web folder, open the Source folder, and click on our status file. First, we define our function by exporting it so that other files in our project can import it. The function takes the subscription object as its only argument. But before we process that data, I want to make sure our app is completely safe from crashing. I will ask Develow, our second prompt, what is the safest way to prevent our application from crashing if the database returns an empty or null subscription object? The AI suggests implementing a guard clause right at the very top of our function. Following this advice, we write an if statement checking if the subscription does not exist. If it is missing, we immediately return a fallback object with an unknown label and a neutral tone. We use the exclamation mark as the logical not operator to check for this empty state. By using the AI's guard clause strategy, we gracefully prevent property access errors that would normally break the application if it tried to read data that simply isn't there. And here is our code block up on the screen. Let's break down exactly what it is doing. We start with a standard if statement, and inside the condition, we place an exclamation mark right before the word subscription. In JavaScript, that exclamation mark is the logical not operator, so this line is literally asking, is the subscription data missing, null, or undefined? If the data is missing, the condition becomes true, and the code jumps inside the block. Here, the return keyword immediately stops the entire function from running any further and instantly hands back a safe fallback object with the label set to unknown. With our functions safely guarded, we need to extract the data fields from the object. To keep our code clean, I will ask Develow, our third prompt, what is the cleanest JavaScript syntax to unpack the status and cancel at period end properties from this object? Let's take a look at the recommendations. The AI highly recommends object destructuring. Based on this guidance, we create a constant block that extracts the status and the cancel at period end variables directly out of the subscription object. This turns a complex object path into simple, independent local variables. It keeps our scope beautifully clean, ensuring that if our data structure ever changes in the future, we only have to update this single line, and here is our code for this. Next, we need to handle a very specific grace period condition from our problem matrix. I will ask the AI, our fourth prompt, how should I handle a scenario where a user has two overlapping conditions, like having an active status, but also having their cancellation flag set to true? The AI explains that handling these overlapping conditions is all about precedence. If a user is active but cancelling soon, that cancellation flag must win so we can warn them. The AI advises that we absolutely must order our logic from most specific to most general. Following this critical rule, we write our priority logic block. We create an if statement checking if the status is exactly equal to active, and simultaneously if the cancel at period end flag is true. If both are true, we return an object with a label saying cancels at period end paired with a warning tone. Because we placed this at the very top to establish the correct precedence, we ensure this specific rule isn't accidentally bypassed by a general active check later on. And here is our next code block up on the screen. Let's look at how we handle our most specific business rule. We write another if statement, and inside the condition, we check if the status is exactly equal to active, and simultaneously if the cancel at period end flag is true. We connect these two conditions using the logical AND operator, which is represented by the double ampersand. This means the entire block will only trigger if both pieces of information are true at the exact same time. If a user matches this exact scenario, the code steps inside the block and executes the return statement. It instantly sends back an object with the label set to cancels at period end and the tone set to warning, which will give our user interface a yellow warning badge. We deliberately place this complex, multi-condition check at the very top of our logic chain because it is the most specific case we have. If we didn't check for this first, a standard check for an active status later down the line would accidentally catch these users and give them a normal green active badge, completely hiding the fact that their subscription is about to end. Now we need to map the rest of the standard database statuses. I will consult the AI with our fifth prompt. What is the most readable way to route multiple distinct string values without writing a long, messy if-else chain? Let's take a look at the recommendations. The AI suggests using a switch statement. It explains that a switch statement acts as a high-performance routing machine, evaluating the variable exactly once and jumping straight to the match. So we define our switch block to evaluate our status variable. Inside, we write our individual cases exactly as the requirement matrix dictates. For the active case, we return an active label and success tone. For the trialing case, we return a trialing label and info tone. For the past due and unpaid cases, we return a past due or unpaid label and a danger tone because they represent urgent payment errors. For the incomplete case, we return an incomplete label and a warning tone. And for the cancelled case, we return a cancelled label and a neutral tone. The moment a match is found, the return statement exits the function immediately, sending the correct badge to the UI. And here is our final code block. We are using a switch statement, which acts like a high-speed router. It looks at the status variable and instantly jumps to the matching case, returning the correct label and color tone from our matrix. The moment it finds a match, it returns the object and exits. Finally, we are almost done, but I want to ask the AI one last question for our sixth prompt. How can I future-proof this logic, just in case the API introduces a brand new subscription status that we haven't mapped yet? Let's take a look at the recommendations. The AI notes that third-party APIs can introduce new data at any time, and it heavily recommends adding a fallback mechanism. To finish our code, we close our switch block with a default case as our safety net. This default case returns an unknown label and a neutral tone. This ensures that even if an entirely new, unmapped status appears in our database, the UI remains perfectly intact and simply displays a neutral badge. We are finished coding. Let's save our work and run the tests. Since Develow is deeply integrated, we just trigger the test runner directly through the terminal panel at the bottom. Watch as the terminal compiles. And there it is, a 100% pass rate. By using Develow AI to first understand the subscription data model and then allowing it to guide every single step of our architecture, we built a bulletproof, professional-grade solution. Great work today, everyone. See you in the next walkthrough.